for example, and I want to refer to the binder clips data set that we used in module 2. Let's see if I can open that data set so that we can have a look at it. So here's the binder clip data set that we looked at in module 2, and I will remind you that I measured 10 binder clips once each, and that produced those summary statistics. Okay, and in particular, the thing that I want to concentrate on at the moment is that standard deviation. And when I took one of those binder clips and remeasured it, I got these summary statistics, and my primary interest here is that sample standard deviation. And the question that I want to think about answering is, what do these summary statistics tell me about the real variability clip to clip in these binder clips? This measures real variability binder clip to binder clip plus measurement variability. This measures the device variability, and what I want to do is somehow combine those to make an estimate of the real clip to clip variability. So let's do some calculations based on those binder clip data. In the first place, this sigma hat sub x is the difference between, is the square root of the difference between 0.0254 squared s squared sub y and 0.0035 squared, that is 0.0252. That's in the original units of millimeters. The Satterthwaite approximate degrees of freedom are then 0.0252 squared over not squared, fourth, better get that one right, 0.0254 to the fourth over, well, I measured 10 different binder clips once each, so 10 minus 1 is 9. I measured one binder clip 7 times, that is and I got a standard deviation of 0.0035, then I'm going to take to the fourth power, and 7 minus 1 is 6, and if I do the arithmetic, that turns out to be 8.7. I'm going to take that approximate degrees of freedom and I'm going to round down to 8, and I'm going to then make 95% limits for this process standard deviation as follows. I'll take the 0.0252 and I'll multiply by a square root of 8, this number over here, over an upper chi-square percentage point. So I want the upper 2.5% of the chi-square distribution. So this is upper 2.5 percent point of chi-square 8, and 0.0252 multiplied by the square root of 8 over 2.180, and that 2.180 is the lower 2.5 percent point of chi-square 8. When all is said and done, this number is 0.017. This number, well, 0170 to one more decimal place. This number is 0.0483. Those are both in millimeters. And what I've learned from this analysis is that the binder clip standard deviation is someplace between about 0.02 millimeters and 0.05 millimeters. Now, that's not a very definitive statement, but that's what I can say based on these samples of size 10 and 7 that I used in this little class demonstration. What I've demonstrated for you here is a first simple way of separating process variation sigma sub x from measurement variation called sigma device in this context.